Good afternoon, guys. As you can see, I am not with you this afternoon. Unfortunately, over Thanksgiving break, my grandmother passed away, and we are having her funeral and burial today. So I will be back with you tomorrow. Your grades for your quiz are in progress book. I did instruct the substitute to pass them back to you so you can use this class period to make corrections if you need to. And then please turn those back into him so I can give you your points for your corrections. So we'll go through our lesson today via video, and then you'll have some homework to do, and then I'll check that homework in on Tuesday. All right, so here we go. We are going to start talking about logarithms. Not a very popular topic with students at all, but we just finished talking about exponents. So exponents and logarithms are very related. In fact, a logarithm is actually an exponent. So first and foremost, let's recall what exponential functions look like. Okay, so we have f of x is b to the x power. Of course, the exponent has to be the variable. That's why it's called exponential function. Let's try and find the inverse. Well, to do that, you switch the x and the y. And then you're supposed to solve for y. Well, when you do that, you end up with something like this. What am I supposed to do with that in order to isolate the y? Well, good news for us, we have this thing called the logarithmic function, and it looks like this. Now, hopefully, well, I know you were exposed to this last year in pre-calc. I don't know how much you remember, but we're going to go through the different parts of the logarithmic function. This y over here is the exponent. This b down here, you might have guessed, is the base. And then the x over here, this is the answer. Okay, those are just the different parts of the logarithmic function. This right here, all of this that I just gave you, this is called logarithmic form. Okay, well, if this is logarithmic form, I can use all of those pieces to rewrite it like this. Notice our base is b, the exponent is the y, and then the answer is the x. This is called exponential form. So we should be able to go back and forth from logarithmic form to exponential form. You'll notice that this exponential form is the same exact representation as the inverse of the exponential function. Okay, so they are the same. Like I told you, the logarithmic function is related to the exponential function. So let's practice going back and forth. So if I asked you to write these in exponential form, you're going to use those different pieces to write yourself an equation with an exponent in it. Well, the base is 3, the exponent is 2, and the answer is 9. So I just converted that into exponential form, and of course that's a true statement. 3 to the second power is 9. All right, let's try it again. My base is 10, my exponent is -3, and the answer is 1 over 1,000. Well, you know that if it's a negative exponent, it pushes it to the bottom. If you push this to the bottom, it becomes 1 over 10 to the third. Well, 10 to the third is 1,000. So again, we've converted a log to an exponential equation, and in fact, it is a true exponential equation. All right, number 3 here. Let's switch it around. Well, that should make sense to you because anything to the 0 power is 1. Okay, now we come across this funny looking thing in number 4, that ln. That is called the natural log. Now, the natural log is its own special kind of representation. All the natural log means is it's a log to the base of e. Okay, log base of e. So over here we had a base of 6, up here we had a base of 10. Now if it's an ln, that just means it has a base of e. Okay, so if I'm going to rewrite this, this will be e to the 0 equals 1. Well, of course, it doesn't matter what e is. Anything to the 0 power is 1. And you should know what e is from last section, that base of 2.71, and that number keeps on going. All right, well, if there's no numbers in it should be able to rewrite it as well. So there we just transformed all of those logarithmic equations into exponential equations. Let's go the other way now. Let's take an exponential equation and write it in logarithmic form. So here we go. We have the log of base 2. Now remember, right next to the log is supposed to go the answer. Well, the answer in this case is 32, and then it's supposed to equal the power. So that would be the logarithmic form of that exponential equation. Let's try it again. I have the log base 10 of the answer equals my exponent. Now, one thing I want to make mention to you is in your book, they will not write base 10, okay? If you write a log with no base, it's assumed to be base 10. So either of these answers will be acceptable, but your book will not write the base 10 in there. It's assumed to be base 10 if nothing is written at the base of the log. All right, let's take a look at number 3 here. We have the log base of 1/8 of our answer equals our exponent. Okay. So again, we're just taking these different pieces and we're plugging it in. Log, I'm not going to write my base 10 here, 1,000,000 equals my exponent. If you want to write the 10 in there, you can. No harm done. And finally, let's do one with some variables in it. Log base A of B is 7. So there we go. We've transformed back and forth from logs to exponents. So I think that's good for today since I'm not here. Let's go ahead and give you this homework. Again, use this time to view this video, pause it if you need to, do this homework, and do corrections to your quizzes from before break. Thanks. We'll see you tomorrow.